Let's do problem 47 and 48 on the 1988 E&M multiple choice test. Number 47, 48, here we go. It says, relate to the following configurations of electric charges located at the vertices of an equilateral triangle. Point P is equidistant from the charges. So here's all our choices right here. And then it says, for number 47, in which configuration is the electric field at point P equal to 0? Well, what you're looking for is symmetry, right? Here, look at this B. These two guys are going to push it this way and push it this way, and it's going to pull it in. Obviously, these are not canceling out. The individual electric fields, well, let's just draw them here, here, and here. These are not canceling out. They're adding up, so it's not 0 there. Same thing is happening here. Positive test charge would want to be pushed away and pulled toward. So it's going to go like that. What is this guy going to do? Now, by the way, if I was actually taking the AP test, would I be analyzing each one of these this carefully and taking this much time? No. Look, I've been doing this for almost a minute and a half already, and my time would be up. You only get like a minute, whatever, per problem. But I'm in teaching mode here, folks. So here we have positive. This is drawn here. Wait, I'm sorry. It's repelled. It's attracted. It's repelled a lot. So these are not canceling out. And same thing is true here. These are not canceling. There's the only place that's canceling out is this one, right? This guy's pushing. This guy's pushing, and this guy's pushing, and they all serve to cancel out. So the electric field is 0 for A. So number 47, the answer is A, or I guess they're using capital A. Okay, now the more difficult problem is number 48, and it says, in which configuration is the electric field at P, in which configuration is the electric field at P pointed at the midpoint between two of the charges? Well, okay, we know it's not A, right? So let's go A, B, C, D, E. We know it's not A because, that's 0 at A. Now let's look at B. I kind of drew what the fields are doing. This thing is getting pushed down. Is this going through the midpoint? No, so it's not B. Let's look at C. Okay, it's getting pushed up, and it's also getting attracted this way and attracted this way, but these two, their horizontal components cancel, so they're vertical. So look, this is getting pushed straight up, and is that pointed at the midpoint between two of the charges? Well, here's two of the charges, here's the midpoint. Yeah, it's pointed right at it, so the answer is C. And you can see that D and E are kind of like sideways or something, so they're not pointed at the midpoint between two charges. So that's why the answer is C. So what's the big idea? Okay, first of all, the electric field is equal to the force on my little positive test charge that I put at point P. And they're vectors, right? And so, the electric field is what happens to a positive test charge at that point. And electric fields add. So if I want to know the total electric field, is equal to the sum of all the little electric fields. Okay, the electric field, this charge and this charge and this charge, you add them together as vectors to see what the result's going to be. Okay, I think that should answer your question. That make sense?
Yes.
Very good. That is all.